So in this video, I am going to explain about model questions of solutions. So here solutions and colligative properties will be present. We will discuss important models. First question. The depression in freezing point of 0.01 molar aqueous solution of HCOOH solution is 0.0204. Kf for water is 1.86. Assume molarity equal to molarity. What is approximate pH of solution? So here it is given HCOOH. HCOOH dissociation. Since it is weak acid, HCOO minus plus H plus. So initially 100 and here 1 minus alpha, alpha and alpha. Say alpha is degree of dissociation. So therefore delta TF equal to I into Kf into molarity or molality we can take. That is equal to I value. So total number of particles I value equal to 1 minus alpha plus alpha plus alpha. That means minus minus cancels. I equal to 1 plus alpha. So therefore delta TF equal to I into Kf into M. I value 1 plus alpha. Kf value 1.86 into molarity is also given 0.01. 0.01. So and delta TF is also given, which is 0.0204. Right here. So very important model. So delta TF is depression freezing point 0.0204 is given. So from this 1 plus alpha equal to 1.096. So that is alpha is 0.096. From this H plus concentration equal to H plus concentration C alpha. C alpha means C is concentration of that acid, that is 0.01 into alpha value. Alpha value is 0.096. So therefore we'll get H plus concentration equal to 9.6 into 10 power minus 4. Therefore pH will be equal to approximately 3. So answer 3. pH is 3. So here at time t equal to 0 and after some time. Total number of particles I equal to after dissociation total number of particles. Next. So what is the elevation in boiling point? For a solution of K2SO4 having molality 1.96, assume 100% dissociation of K2SO4. Elevation in boiling point. Delta TB equal to I into Kb into M, molality. So from this delta TB equal to, so Van 't Hoff factor for K2SO4 dissociation 2K plus SO4 2 minus. Therefore here I value equal to 3 particles. So I value 3 and here Kb, it should be Kb. Molar elevation constant Kb 0.51 into molarity 1.96. Therefore, delta TB equal to 3. So answer is 3. Next. The next question. So what is depression in freezing point for 0.5376 molar aqueous solution of AlCl3? Assume 100% dissociation of AlCl3. So Kf is given 1.86. Here 1.86 should be there. 1.86 Kelvin kg per mole. %% dissociation. So 100 grams of solvent should not be there. Kelvin kg per mole. That's all. So what is depression in freezing point for 0.5376 molar aqueous solution of AlCl3? Simply. This is also similar question. Delta TF equal to I into Kf into molarity, that is I value. So AlCl3 dissociates to Al3 plus 3Cl minus. So I value equal to 4 particles. 4 into Kf value 1.86 into molarity 0.5376. So this value will be 4. Therefore answer is 4. Remember here dissociation. AlCl3 produces 4 particles. Next. So 0.1 molar mono basic acid has osmotic pressure equal to 2.69 atmospheres. 2.69 atmospheres at 25 degrees centigrade. What is its pH? So here simple question, this one also. So weak acid, monobasic acid, I am taking Ha as weak acid. It gives H plus and A minus ions. So pi equal to I into CST. So pi is given 2.69 osmotic pressure atmospheres into I value. Here 2 particles. Here I value equal to 1 plus alpha into n minus 1 in case of dissociation. Here n equal to 2. Therefore, I value equal to 1 plus alpha into 2 minus 1. That is alpha equal, and that means I equal to 1 plus alpha. So 1 plus alpha into C is concentration. So concentration is 0.1 into solution constant 0.081 liter atmosphere per mole per Kelvin. Next temperature 298 kelvins. So from this alpha equal to 0.1. Therefore H plus equal to C alpha. C is concentration 0.1 into 0.1 10 power minus 2 molar. Therefore pH equal to 2. 2 is the answer. Next. 3 moles of liquid A and 2 moles of liquid B are mixed together. The vapor pressure of mixture in centimeters at the same temperature is. So we know P total equal to P naught A into XA plus P naught B into XB. That is equal to P naught A 5 into, so P naught is vapor pressure of A 5 centimeters into mole fraction. So 3 by 2 plus 3 mole fraction. So into P naught B 10 is given, 10 into 2 by 2 plus 3. So which is equal to, so here 3 by 5, that is 3 plus 4, which is equal to 7 centimeters. So P total equal to 7 centimeters. 7 is the answer. Next. So this is also very important. 0.001 molar solution of a complex is given ANH3 4 times Cl4 in water has a freezing point depression 0.0054 degrees centigrade. If Kf equal to 1.86 Kelvin kg per mole or Kelvin into molality inverse for water, how many Cls are attached as ligands? Assume 100% dissociation of complex. So take here total n moles of, so very important model. Take n moles of Cl acts as ligand. So we can write formula A NH3 4 times ClN and here Cl 4 minus N. So it dissociates to ANH3 4 times ClN plus 4 minus N into Cl minus. This is dissociation. So take here initially 1, 0, 0 at time t equal to 0. So after some time completely dissociated, that means 100% dissociation, therefore it gives 1 and here 4 minus N ions. So therefore I value equal to 1 plus 4 minus N, total number of particles, that means 5 minus N I value. So therefore delta TF equal to I into Kf into molality. Next. So depression freezing point is given 0.0054. Here I value 5 minus N. Kf 1.86. Molality 0.001. So from this we will get N value as 2. So 2 chlorines are attached as ligands. Therefore formula is A NH3 4 times Cl2 and 2 Cls outside. This is the formula of complex. Complex formula. So 2 Cls are acting as ligands and 2 Cls are outside of complex. So very important. Next. So vapor pressure of a mixture of two volatile liquids expressed as P total equal to or pressure of mixture equal to 6 plus 1.5 into mole fraction of B, where Xb mole fraction of B in mixture. The vapor pressure of A at the same temperature is a simple pressure of mixture equal to P naught A XA plus P naught B XB. So according to Raoult's law, therefore Pm equal to, so here in expression only XB is there. That means I am replacing XA with 1 minus XB plus P naught B into XB. Therefore Pm equal to P naught A plus P naught A XB. Here minus should be minus P naught A minus P naught A XB plus P naught B XB. So which is equal to finally P naught A plus XB common P naught B minus P naught A. This is the expression. So compare this expression with given expression Pm equal to 6.0 plus XB into 1.5. This is given. So from this, the vapor pressure of A, which is P naught A equal to 6. Simple question. Next, from P naught B minus P naught A equal to 1.5, we can find P naught B value. So answer 6. Next. Van de Hoff factor of a mixture of 2 moles of Ki and 1 mole of HgI2 in aqueous solution of water is Van de Hoff factor, that is 2 moles of Ki potassium iodide and 1 mole of HgI2 gives K2HgI4. K2HgI4. So it dissociates to 2K plus HgI4 2 minus. So if it is 100% dissociation, I value equal to here 2 ions and here 1 ion. 1 ion is present. Therefore 2 plus 1, 3. So which is equal to N also. So if 100% dissociation is present, I equal to N. N is number of particles produced after dissociation. Therefore I value equal to N value equal to 3. Next. So boiling point of a solution of 5 grams of sulfur in 100 grams of CS2 carbon disulfide is 0.5 degrees above pure solvent. That is, in total delta TB is given. Kb for CS2 is 2.56 Kelvin molality inverse. Then atomicity of sulfur in the solvent is, atomicity we should find. Simple question. Delta TB equal to, here no need to take I value because ionic compound is not present. Kb into molality. Kb into molality can take Wb by Mb into 1000 by Wa. So here B for solute and A for solvent. W is weight, M is molecular weight. So delta TB is given 0.5 equal to Kb value 2.56 into weight of sulfur, which is 5 grams, by molecular weight we must find into 1000 by WA, so 100 grams. So from this molecular weight will be equal to here 10 times. Therefore MB equal to, so by solving, MB is molecular weight of solute. So 50 into 2.56 divided by 0.5, 256. So total molecular weight. Therefore atomicity of sulfur equal to MB by 32. 32 is the atomic weight of sulfur, that is 256 by 32. We get 8. So therefore S8 is present, octaatomic. So octaatomic sulfur is present. Therefore atomicity means total number of atoms in one molecule. Answer is 8. S8 octaatomic sulfur. Next. A solution containing 8 grams of carbohydrate. 8 grams of carbohydrate, molar mass 0.374, not 0.374, it should be, 1 second, 8 grams of carbohydrate, molar mass, I think it should be 374 per mole, that means mole inverse, in 100 grams of water has density 1.025 grams per ml. So what will be osmotic pressure? So first I will write weight of solution equal to weight of solute plus weight of solvent. So weight of solute is 8 grams plus weight of solvent 100 grams. Therefore it is 108 grams. Therefore volume of solution equal to, so weight by density. So weight 108 by density 1.025, which is ml. So 108 by 1.025 by 1000 liters. By 1000 liters. This is volume. Next, temperature is given as 27 degrees centigrade, that is 300 kelvins. So here pi V equal to W by M into ST. So from this you can find pi equal to osmotic pressure equal to, so weight 8 by, so molecular weight 374, it should be 374, molar mass 374 grams into, so S value 0.081, solution constant value, into 300 temperature, so divided by 108, so here into total into 1.025 into 1000. This is total value. 1 second. So into 1.025 into 1000, that is 10 cube. So from this pi value will get 5. In atmospheres, they are asking in atmospheres. Answer is 5. Very, very important. First, weight to volume conversion. Next, temperature is given. Pi v equal to weight by molecular weight into solution constant into temperature. Direct question. Next, an aqueous solution of a substance, molar mass 240, has osmotic pressure 0.2 atmosphere at 300 kelvins. Density of solution in grams per decimeter. That means grams per liter will be. So here first, aqueous solution of substance, molar mass is given. Osmotic pressure. So pi equal to, or pi v equal to, first W by M into ST. So osmotic pressure 0.2. Next, volume, you should find volume. Weight we should find. Weight by volume density. So M 240 into S value 0.08 into temperature 300. So here weight must be in grams. Volume must be in liters. So therefore, density equal to W in grams by volume in liters equal to W by 0.2 into 240 divided by 0.08 into 300. So this value approximately will be, so 0.2, 240 into 0.2 divided by 0.08 divided by 300, which is equal to 2. Therefore, density is 2 grams per liter. This is the answer. 2 grams per liter. Next. So 3 moles of liquid A, 3 moles of liquid A, vapor pressure 60 mm, and A moles of B, A moles here. A moles of B, vapor pressure 40 mm, results a solution having vapor pressure of 50 total. So value of A is, so simply pressure of mixture equal to P naught A XA plus P naught B into XB. So total pressure 50 is given. P naught A 60 into mole fraction. So 3 by 3 plus A mole fraction plus P naught B 40 into A by 3 plus A. So by substitution, you can say therefore A value will be equal to 3. So 3 moles. 3 moles of B is present. So total 30 plus 20, 50. 50 will get total pressure as 50. Next. The moles of BaNO3 twice, which are dissolving in 12 moles of water, lowers the vapor pressure of water to 80. Number of moles of solute we should find. Here BaNO3 twice is solute. So vapor pressure, relative lowering of vapor pressure. Vapor pressure equal to delta P by P naught, which is equal to mole fraction of solute. So mole fraction of solute means number of moles of solute by number of moles of solute plus number of moles of solvent. So from this we should find number of moles of solute. So delta P is again P naught minus Ps. So delta P by P naught equal to P naught minus Ps by P naught equal to, say, number of moles of solute small n, number of moles of solute small n, and capital N, number of moles of solvent. So from this we can write N by N plus N. So it is given pressure reduces to 80. That means if we take P naught as 100, Ps becomes 80 by 100 equal to, so N we should find N. N is, small n is number of moles of solute. And write here N by N plus, here 12 moles of water, 12 moles. So by solving we'll get N value as, so simple, here 20 by 100. So that is 0.2. Therefore N value 1. Therefore number of moles of BaNO3 twice equal to 1. 0.2 equal to N by N plus 12. Number of moles will be 1 mole. Next, here one more point. We must add Van 't Hoff factor also, because here ionic compound is given BaNO3 twice. So here also I value. We must add Van 't Hoff factor. Here also Van 't Hoff factor. Van 't Hoff factor. So Van 't Hoff factor BaNO3 twice dissociates to Ba2 plus and 2NO3 minus. Therefore, I value equal to 3. So from this we'll get N value as 1. Number of moles of BaNO3 twice. Next. So depression freezing point of 1 mole of Na3PO4. Here P capital. Sodium phosphate is dash times depression in freezing point of 1 mole of NaCl. Alpha equal to 1 means 100% dissociation. 100% dissociation. So very important. See here, depression freezing point delta TF for Na3PO4 by, so delta TF for NaCl. So molality is same, Kf is same, that is Van 't Hoff factor for Na3PO4 by Van 't Hoff factor for NaCl. So here Van 't Hoff factor Na3PO4 dissociates to 3Na plus PO4 3 minus. NaCl dissociates to Na plus and Cl minus. So here Van 't Hoff factor 3 plus 1 4. Here Van 't Hoff factor 1 plus 1 2. Therefore 4 by 2. Therefore 2 times. So depression freezing point for Na3PO4 is twice, 2 times. That of depression freezing point for NaCl. 2 is the answer. Next. in equimolar solutions of THNO3 4 times THNO3 4 minus and NaCl. If depression freezing point for NaCl is noticed by 2 times, depression freezing point for THNO3 4 times will be. So here Van 't Hoff factor for NaCl, I value equal to 2. So because NaCl dissociates to Na plus and Cl minus, I value equal to 2 ions. Next for THNO3 4 times, I value equal to 5. That means THNO3 4 times dissociates to TH4 plus 4NO3 minus I value equal to 1 plus 4, 5. So, if depression freezing point, that means depression freezing point directly proportional to I. So, for NaCl, depression freezing point equal to 2. Therefore, depression freezing point for THNO3 4 times is 5. Clearly 5 is the answer. Depression freezing point directly proportional to I. Next. So Van 't Hoff factor for THNO3 4 times in aqueous solution is Van 't Hoff factor. So THNO3 4 times dissociates to TH4 plus 4NO3 minus. So total number of ions I equal to 1 plus 4, which is equal to 5. So that is equal to N also, number of particles after dissociation. Simple question. Total number of particles after dissociation. If it is 100% dissociation. If it is 100% dissociation. Very, very important. Next. So an equimolar solution of benzene and toluene having vapor pressures. So this is also important. Benzene and toluene having vapor pressures of benzene and toluene in vapor phase are X and Y respectively. If vapor pressure of benzene and toluene in pure state are in the ratio 1:3, what is X by Y? X by Y. So first, pressure of benzene in vapor state equal to P naught B into XB dash. Similarly, PT dash equal to P naught T into XT dash. Next again, mole fraction equal to total pressure into XB, XT dash equal to PM into XT. So first one Raoult's law, next one Dalton's law. So mole fractions X and Y. Next XB dash by XT dash equal to, that means into P naught B by P naught T equal to XB by XT. XB by XT. So here it is given Xb by Xt, Xb by Xt equal to P naught B by P naught T. So which is equal to, so here P naught T by P naught B is given 1 by 3. Therefore, 3 value 3. So check here, answer is 3. So since Xb dash Xt dash equal to 1 by 2, equimolar mix is given, equimolar, mole fraction 1 by 2, 1 by 2. Simple one. So for benzene, vapor pressure X and for toluene Y, that is Xb by Xt equal to 3. Next. This is also important. Which of the following on addition in 1 molar Ka solution will give rise to increase in vapor pressure? Increase in vapor pressure. That means if Ki is added to Hgi2, take a 2 moles of Ki, it gives K2 Hgi4. So here number of particles decreases. Particles in solution decreases. So as the number of particles decreases, vapor pressure of solution increases. As the number of particles decreases, vapor pressure of solution increases. Therefore, option A. So by the addition of Hgi2, mercury iodide to Ki solution, so there will be decrease in number of particles. So we know colligative property from this, delta P equal to P naught, which is equal to P naught minus Ps by P naught, which is equal to I into mole fraction of solute. This is the relation. P naught is constant. Therefore, minus Ps directly proportional to I. This is the relation. Minus Pa directly proportional to I. That means as the I value decreases, Ps value increases. This is the relation. Minus Ps inversely proportional to I. As the value of I increases, Ps decreases. Here I decreases means Ps increases. Vapor pressure of solution increases. Next. So ratio of any colligative property for 1 molar FeCl3 and 1 molar glucose solution. So for FeCl3, I value equal to 4. That means FeCl3 dissociates to Fe3 plus 3Cl minus. So here I value equal to 1 plus 3, 4. Next for glucose, I value always will be equal to 1. No dissociation. So therefore, ratio is 4 by 1, which is 4. Simple. Any colligative property directly proportional to I. Next. So when mercury iodide is added to aqueous solution of potassium iodide, Ki plus Hgi2, take here 2 moles. So K2 Hgi4. K2 Hgi4. So the number of particles in solution decreases. number of particles in solution decreases. That means depression freezing point delta TF equal to freezing point of solvent minus freezing point of solution equal to I into Kf into M. So Kf, M are constant, therefore freezing point of solvent also constant. Therefore minus freezing point of solution directly proportional to I. So here I value decreases. Number of particles decreases means I value decreases. So as the I value decreases, freezing point of solution increases. So therefore freezing point is raised. Option A. So minus freezing point directly proportional to I. As the I value increases, freezing point decreases. So I value decreases. Therefore freezing point increases. Option A. Next. So colligative properties will depend on number of solute particles in solution. So Van 't Hoff factor. So any colligative property depends on number of solute particles in solution. Number of solute particles in solution. So therefore clearly option A. Number of solute particles dissolved in solution. Next. The correct relationship between boiling points of very dilute solutions. Boiling points of very dilute solutions of AlCl3, CaCl2 at the same molar concentration. So here delta Tb first, delta Tb I into Kb into M. So here Kb and M are constants, therefore delta Tb directly proportional to I. So delta Tb means boiling point of solution minus boiling point of pure solvent directly proportional to I. So boiling point of solvent also constant, therefore boiling point of solution directly proportional to I. This is the relation. So as the I value increases, boiling point increases. So for AlCl3 dissociates to Al3 plus 3Cl minus, I value equal to 4. CaCl2 Ca2 plus 2Cl minus, I value equal to 3. So I value more for AlCl3. Therefore boiling point of AlCl3 greater than boiling point of CaCl2 solution. So here it is T1. Therefore T1 greater than T2. Option B. Very, very important. Next. The value of Kf for water is 1.86. 1.86. Calculated from glucose solution. the value of Kf for water calculated from NaCl solution will be. See here, Kf and Kb. Kf depends only on solvent. Depends only on solvent. That means characteristic property of solvent. That means property of only solvent. That is independent of solute added. So therefore, Kf equal to same 1.86, option A. So Kf is constant for a given solvent. If solvent is same, Kf will be the same. That is independent of the amount or nature of solute. Equal to 1.86. Next. So which is not a colligative property. So your colligative properties are right here. Colligative properties for relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. These are colligative properties. So depression, freezing point, here elevation in boiling point, depression in freezing point. So freezing point is not colligative property. Depression freezing point is colligative property. Therefore B. Very, very important. Osmotic pressure pi. So this is delta P by P naught. Delta P by P naught. Next. So which solution of mass by mass will have highest boiling point? Highest boiling point. Highest boiling point. So calculate for here Van der Waals factor. Glucose I value 1. Next sucrose I value 1. Next NaCl I value 2. CaCl2 I value 3. So boiling point highest. So calculate delta Tb. So as the delta Tb increases, boiling point of solution increases. Next, and the delta Tb, one second. Next one, check here. So delta Tb inversely proportional to molecular weight of solute. Molecular weight of solute. So from this we can say 1% solution of NaCl in water has highest boiling point. So based on these two. Simple question. Next question. A substance is completely trimerized on dissolution in a solvent. The Van der Waals factor I. So trimerization. So for association of solute in solution, comma, we have I value equal to 1 by n. In case of trimerization, comma, I value equal to 1 by 3. That is equal to 1 by n. Simple question. Option D. D should be there. Option D. 1 by 3. For dimerization 1 by 2, trimerization 1 by 3, tetramerization 1 by 4. Like that. Next. The molar mass of benzoic acid in benzene determined by depression freezing point method corresponds to dimerization of benzoic acid. C6H5 COOH benzoic acid. Take 2 moles. C6H5. Here OH. Here double bond O. Here there is formation of dative bond, not dative bond, hydrogen bond. Intermolecular hydrogen bond. Dimer of benzoic acid. Molecular association. So dimerization in benzene solvent. Therefore, option B. Next. The depression freezing point of 0.01 molar aqueous solutions of urea, sodium chloride, sodium sulfate in the ratio of. So depression freezing point directly proportional to I. So for urea, I value equal to 1. For NaCl, I value equal to 2. Why 2 means Na plus and Cl minus, 2 ions. Sodium sulfate, Na2SO4. I value is 3 because 2 Na plus SO4 2 minus. So therefore, delta TF for urea, NaCl and Na2SO4 ratio is equal to 1:2:3. Option B. Next. So aqueous solution of 0.004 molar Na2SO4 and 0.01 molar glucose are isotonic. Degree of dissociation of Na2SO4. So here I am taking Na2SO4 and here glucose. These two are isotonic. Therefore, say this is pi 1 and pi 2. So pi 1 equal to pi 2. So here I into CST. So here also I into CST. So here I value equal to 1 for glucose. Next, therefore, here concentration S and T are constant. Therefore, I into concentration of Na2SO4 equal to C, concentration of glucose. Here I value into concentration of Na 0.004 equal to here 0.01. So from this I value equal to 0.01 by 0.004. So this value will be 0.01 by 0.004, 2.5. So in case of dissociation, alpha equal to I minus 1 by n minus 1. I value 2.5 minus 1 by n minus 1. So for Na2SO4, 2Na plus SO4 2 minus. So n value is 3 particles. By 3 minus 1, 2. So that means simply 2.5 minus 1.5 by 2. That is 0.75 or 75%. Option C. Next. So freezing point of equimolar aqueous solutions will be highest for here NH3 plus Cl minus should be there. So first C6H5 NH3 plus Cl minus. So for this Van der Waals factor is 2. For CaNO3 twice, that means Ca2 plus 2NO3 minus Van der Waals factor is 3. For LaNO3 thrice, La3 plus 3NO3 minus Van der Waals factor 4. And for C6H12O6 glucose, Van der Waals factor is 1. So freezing point of solution. So minus freezing point of solution directly proportional to I. So this is the relation. So as the I value increases, freezing point decreases. So here I value is least for glucose. Therefore it will be having highest freezing point. Therefore glucose C6H12O6 solution has highest freezing point. So due to lowest I value. Since I value is lowest, it is having highest freezing point. So minus freezing point of solution directly proportional to I. So as the I value decreases, freezing point of solution increases. Therefore option D. So this is the end of the chapter. In next video, I will explain some more questions. All the best and thank you.